Right now, you're moving. Not because you got up, not because the earth is spinning, though it is at about 1,000 miles per hour. Not because our solar system is orbiting the center of the Milky Way, though it is at roughly 500,000 miles per hour. You are moving towards something else entirely, something invisible, something we cannot directly observe, something that sits hidden behind the densest, most obscuring region of our own galaxy, and yet exerts a gravitational pull so enormous that it is dragging every galaxy in our neighborhood through space at over 1,000,000 miles per hour. We've known about it for nearly 40 years. We've mapped the edges of its influence across hundreds of millions of light years. We've watched it pull 100,000 galaxies, including ours, in one relentless, inexorable direction, and we still don't fully know what it is. What the data reveals when you finally let yourself look at it, really look, will change the way you understand your place in this universe. We'll get to that, but not yet. First, let's go back to 1987. 7 astronomers at the Carnegie Institution in Pasadena, California, were doing something that sounded, on the surface, completely routine. They were measuring the velocities of elliptical galaxies, cataloging how fast distant island universes were moving through space. These 7, Alan Dressler, Sandra Faber, David Burstein, Roger Davies, Donald Lyndon Bell, Roberto Turlovich, and Gary Wegner would later be nicknamed the 7 Samurai, not because of the danger, because of the audacity of what they took on. 7 people attempting to map the large-scale motion of the known universe. Their method was precise. Elliptical galaxies follow a predictable relationship between their size, their brightness, and the velocity at which their stars move internally. Measure 2 of those properties, and you can calculate the third. Then you compare what the galaxy should look like at that distance with what it actually looks like in the sky. The discrepancy tells you whether it's moving toward you or away from you at a speed that the universe's expansion alone cannot explain. Astronomers call this a peculiar velocity. The word is apt because what the 7 samurai found was deeply, profoundly peculiar. Every galaxy they measured, hundreds of them, spread across enormous regions of sky, was moving, not randomly, not in scattered directions the way you might expect from chaotic gravitational interactions. They were all moving in the same direction, toward the same point, including us. Dressler stood in front of the American Astronomical Society in January of 1987 and told his colleagues that the Milky Way, along with what appeared to be millions of neighboring galaxies, was being pulled through space at roughly 600 kilometers per second. Not by a star, not by a black hole, by something so massive, so diffuse, and so perfectly hidden from direct observation that it had no precedent in the scientific literature. He called it the Great Attractor. Here's where it gets strange. 600 kilometers per second sounds abstract. Let me make it concrete for you. In the time it took you to read that last sentence, just those few seconds, our galaxy moved approximately the same distance as from New York City to Los Angeles. We have been moving at this speed for billions of years. Every civilization that has ever existed, every war ever fought, every star ever named by a culture that no longer exists, all of it happened while we were already in motion, already being pulled, already falling towards something we couldn't see and didn't know was there. That is the scale of what we're dealing with. And we've only just begun to understand what's doing the pulling. The problem wasn't the discovery. The problem was what came next. When Dressler and the 7 samurai pointed their colleagues toward the source of this gravitational pull toward the region of sky. Where this enormous, invisible force was originating, they ran straight into one of the most frustrating obstacles in the history of astronomy. The Great Attractor is hiding, not metaphorically, not in the sense that it's faint or far away. It is physically concealed behind the one thing in the universe we cannot see through with ordinary instruments, the plane of our own galaxy. Picture this. You're standing in the middle of a vast, dark plane at night. You want to see what's on the other side of the horizon, but between you and that horizon sits a wall made of billions of stars, compressed into a band of blazing, impenetrable light. Laced through that wall are enormous clouds of gas and dust, molecular clouds so thick that visible light cannot pass through them. And behind that wall, somewhere in the darkness on the other side, is the thing that's been pulling you forward your entire life. That region of sky has a name. Astronomers call it the Zone of Avoidance. It earned that name honestly. For most of the 20th century, sky surveys simply skipped it. There was no point trying to map what you couldn't see. The Zone of Avoidance swallowed a full 20% of the observable sky, and the Great Attractor sat almost perfectly in the middle of it. But this is the part nobody talks about. Even without seeing it directly, we knew something was there, because the math didn't lie. The peculiar velocities of hundreds of galaxies all pointed to the same region. The gravitational fingerprint was unmistakable, like feeling the pull of a tide without being able to see the moon. So astronomers did what astronomers do when visible light fails them. They looked into other wavelengths. X-ray telescopes began to cut through the obscuring dust. Infrared surveys followed. Radio astronomers tuned their instruments to the frequency of neutral hydrogen, a signal that travels through gas clouds the way a foghorn carries through fog. And what they found, piece by piece, was staggering. The Great Attractor is not a single object. It is a region, a gravitational basin, and at its approximate center sits something called the Cluster, a dense congregation of thousands of galaxies, all locked together by gravity, all pulling on everything around them with a combined mass that staggers the imagination. But the Cluster alone was not enough to explain the pull. The numbers didn't add up. The mass visible in the Cluster, enormous as it was, could only account for a fraction of the gravitational force being felt across hundreds of millions of light years. Something else was contributing, something larger, something further away. Stay with me. In 2014, a team of astronomers led by Brent Tully at the University of Hawaii published a paper in the journal Nature that reframed everything we thought we understood about where we live. They had mapped the flow of galaxies across an enormous volume of space, hundreds of millions of light years in every direction, and used those flows to define the boundaries of a structure so vast it had no name yet. They gave it one, Laniakea, a Hawaiian word meaning immense heaven. Laniakea is our home supercluster. It contains roughly 100,000 galaxies, including the Milky Way, the Andromeda Galaxy, the Virgo cluster, and thousands of others, all slowly gravitationally flowing toward a single point. That point is the Great Attractor. Think about what that means. You are not just a person on a planet. You are a person on a planet, inside a solar system, inside a galaxy, inside a supercluster of 100,000 galaxies. And that entire supercluster is oriented around one invisible gravitational center, like water circling a drain. If our entire Milky Way galaxy were the size of a single grain of sand, Laniakea would be the size of a football stadium, and the Great Attractor is the lowest point of that stadium's floor. Everything is falling toward it, including everything you have ever loved. Here is where most people stop the story. The Great Attractor pulls us. We can't see it. It's enormous. End of video. But that version of the story is incomplete because the moment you pull back far enough, the moment you zoom out past Laniakea, past the normal cluster, past the hundreds of millions of light years we've already covered, you find something that makes the Great Attractor look almost modest, and it gets worse. The Great Attractor is not the bottom of the gravitational well. It is just a ledge on the way down. Behind it, 650 million light years from Earth, in the same general direction as the constellation Centaurus sits, the Shapley Supercluster, the largest concentration of mass in the known local universe. More than 8,000 galaxies packed into a volume so dense that astronomers once doubted their own instruments when they first measured it. It's not the Great Attractor alone, and it's not Shapley alone, and it's certainly not some simple tug-of-war between two structures. It's a cascading gravitational hierarchy structure, pulling on structure, supercluster, pulling on supercluster, and we are somewhere near the bottom of it, falling in a direction we only identified 40 years ago. Research published in 2021 confirmed what many cosmologists had long suspected, that roughly 56% of our peculiar velocity, our unexplained motion through space, can be attributed not to the Great Attractor, but to the Shapley supercluster pulling from behind it, the Great Attractor. It turns out, is partly a gravitational echo of something even more powerful lurking further away. We thought we had found the source. We had only found an intermediary. Now, pay close attention, because in 2017, a second discovery was published, one that added an entirely new dimension to this picture. Brent Tully and his team at the University of Hawaii were not just mapping where galaxies were flowing toward us, they were mapping where galaxies were flowing away from. And what they found on the opposite side of the sky from the Great Attractor was something that had never been properly identified before. A void, a colossal, largely empty region of space stretching hundreds of millions of light years across, from which galaxies appeared to be fleeing in every direction. They called it the Dipole Repeller. And here is why that matters. Gravity pulls, but empty space, the absence of the gravitational attraction that normally slows cosmic expansion, effectively pushes. The dipole repeller is not exerting a force in the conventional sense. It is simply a region where there is almost nothing pulling back. And in a universe where matter is distributed unevenly, that absence functions exactly like a push. So consider your position right now. The Great Attractor, and behind it, the Shapley supercluster pulling you forward from one direction, the dipole repeller pushing you from behind in the opposite direction. You're not simply being attracted to something. You are being squeezed, funneled, caught between two of the largest gravitational influences in the observable universe, moving at over 1 million miles per hour toward a destination you cannot see. And you have been in this position since before the Earth existed. Every mountain that has ever risen and eroded, every ocean that has ever formed and evaporated, every species that has ever appeared on this planet and vanished from it, all of it happened in transit. All of it happened while the entire apparatus of life on Earth, 4.5 billion years of it, was being silently carried through space toward an invisible target, compressed between forces so large they make our entire solar system look like a dust mote caught between two searchlights. This is the part that should keep you up at night, because we are not observers of this process. We are passengers in it, and we never bought a ticket. We never chose the destination. We simply woke up, if you can call the emergence of consciousness, waking up already moving, already falling, already aimed at something vast and dark and waiting on the other side of our own galaxy's light. So here is the question that should be forming in your mind right now. If we have been moving toward the Great Attractor for billions of years at over 1,000,000 miles per hour, why aren't we there yet? How long until we arrive? What happens when we do? The answer is one of the most quietly devastating things I have ever encountered in astrophysics. We will never arrive. Not because the distance is too great, though it is. Not because our technology is too primitive, though it is. Not even because the universe is expanding and stretching space between us and everything else, though it is doing exactly that. We will never arrive because the force that is pulling us, the same gravitational basin that has been shaping the motion of 100,000 galaxies across billions of years, will eventually lose. And the thing that will beat it is something you cannot see, cannot feel, and cannot stop: dark energy. Here's what most people don't realize about dark energy. It is not a force in the way gravity is a force. It does not pull or push in any direction you can point to. It is woven into the fabric of space itself, a property of the vacuum, a pressure that exists everywhere and acts on nothing except the expansion rate of the universe. And that expansion is accelerating. Right now, gravity is winning locally. The galaxies of Laniakea are still flowing inward toward the Great Attractor. The peculiar velocities are real. The pull is real. But on the largest scales across the hundreds of millions of light years that separate superclusters, dark energy is already winning. Remote galaxy clusters are receding from us faster than light, not because they are moving through space quickly, but because the space between us and them is growing faster than anything can cross it. And over billions of years, that process will reach inside Laniakea itself, the supercluster we call home the immense heaven. The 100,000 galaxy structure that Brent Tully's team mapped and named in 2014 is not gravitationally bound. This is the part that stops astronomers cold when they say it out loud. Laniakea looks like a structure. It flows like a structure. It has a center, a boundary, and a name. But it is not held together the way a galaxy is held together, or the way a galaxy cluster is held together. It is a temporary pattern, a momentary gathering, a wave that looks solid until you remember that waves are just water moving through water. Dark energy will dissolve it. In tens of billions of years, the expansion of the universe will overcome the gravitational flows that define Laniakea's shape. The galaxies that are currently falling toward the Great Attractor will slow, stop, reverse, not because gravity weakened, but because the space between them will be stretching faster than gravity can bridge it. The supercluster will not collapse. It will not explode. It will simply evaporate, galaxy by galaxy, cluster by cluster. The structure will come apart at the seams until what was once an immense heaven becomes a scattering of isolated islands, each one receding from all the others beyond any possibility of contact. Hold on to that thought, because here is what that means for us. Right now, in this moment, the Great Attractor is real. The pull is real. We are genuinely, measurably, provably falling toward it at speeds that dwarf anything human civilization has ever achieved. And at the same time, we are living inside a deadline, a cosmic window that is slowly, imperceptibly closing. The gravitational era of Laniakea, the age in which the Great Attractor functions as a center, in which 100,000 galaxies share a common gravitational fate, is finite. It had a beginning, it will have an end, and we happen to exist in the middle of it, in the brief window when the structure is coherent enough to observe, old enough to have shaped our motion, and young enough that we have not yet felt the pull of its dissolution. We are not just passengers on this passage through space. We are passengers on a passage that is already ending. In February of 2026, a team of researchers at the University of Oxford published a paper that attempted something remarkable. They built a digital twin of the nearby universe. Using data from the most precise galaxy velocity surveys ever conducted catalogs containing hundreds of thousands of galaxies, mapped across distances of hundreds of millions of light years, they reconstructed the gravitational landscape of our cosmic neighborhood with a fidelity that would have been unimaginable to the Seven Samurai in 1987. Their goal was to answer, with more precision than anyone had before, a question that has haunted cosmology for nearly 4 decades. Where exactly are we going? What they found was both clarifying and unsettling. The Great Attractor concept, they concluded, is real, but it is more complicated than a single destination. The mass responsible for our motion is distributed across an enormous volume. No single point, no single cluster, no single structure accounts for all of it. We are being pulled by a landscape of gravity rather than a peak, drawn into a basin rather than toward a summit. And that basin has no floor we can see. Here's what I want you to sit with for a moment. Not the science, the feeling. There is a version of the human story that goes like this. We emerged on a small planet. We built fire, we built cities, we split the atom and decoded our own genome and sent machines to the edge of the solar system. We looked up at the night sky and we made maps increasingly precise, increasingly vast maps of everything we could see. And then we discovered that we were moving, that we had always been moving, that every map we ever made was drawn on a vehicle traveling at over 1 million miles per hour toward a destination hidden behind the one wall we cannot see through. The Seven Samurai didn't set out to find the Great Attractor. They set out to measure galaxy velocities. They were doing their jobs careful, methodical, unglamorous scientific work when the data handed them something that reframed the entire human position in the universe. Not a discovery you go looking for, a discovery that finds you when you're paying close enough attention. Alan Dressler stood up in front of his peers in January of 1987 and told them the cosmos had a current, that everything was flowing, that the universe was not the static, evenly distributed expanse that standard models had assumed, but something lumpy, directional, shaped by concentrations of mass so enormous, they organize the motion of millions of galaxies across distances that make the word enormous sound quaint. Nobody in that room had language for it yet. They do now, and so do you. Remember what I told you at the very beginning, that right now, as you sit still, you are moving towards something invisible, towards something hidden behind the light of our own galaxy. I told you we get to what it is. Now you know. The Great Attractor is real. The pull is real. The 100,000 galaxies of Laniakea, including ours, are genuinely, measurably falling toward a gravitational center we can feel but cannot fully see, being pushed from behind by a void so large it functions as a cosmic wind, aimed at a destination that dark energy will ensure we never reach. You're on a passage with no arrival. And here's what I didn't tell you at the beginning. Knowing its name changes nothing about your trajectory. You were already moving before anyone gave it a name. You will keep moving long after anyone is left to remember the name. The universe does not require your awareness to pull you forward. It never did. So let me leave you with 3 things. The first, the Great Attractor is not a monster. It is not a threat. It is a gravitational basin, the center of a supercluster containing 100,000 galaxies, located roughly 250 million light years away in the direction of the constellation Norma, hidden behind the zone of avoidance that blocks our direct view. We know it exists because we can feel it. We are moving toward it at 600 kilometers per second, a speed so enormous that in the time you've been watching this video, our galaxy has traveled further than most spacecraft have moved in their entire operational lives. The Great Attractor is real, measurable, and pulling on everything you have ever known. The second, you will never reach it. Not because the distance is too long, but because the universe itself is working against the arrival. Dark energy is accelerating the expansion of space faster than any gravitational pull can compensate across the largest scales. Laniakea, the supercluster we call home, is not a permanent structure. It is a temporary pattern in the fabric of the cosmos, coherent now, dissolving later, destined to evaporate into isolated islands of matter, separated by distances so vast that no signal, no light, no information will ever cross them again. The window in which the Great Attractor functions as a center is open right now. It will not stay open forever. The third, and this is the one I want you to carry with you, every human being who has ever lived, every child who looked up at the stars and wondered, every philosopher who asked why there is something rather than nothing, every astronomer who spent a cold night at a telescope chasing answers, every single one of them made that passage while already in motion, already falling, already being carried by forces so large they make the whole of human history look like a footnote written on a moving train. We are not standing still, looking out at a universe in motion. We are the universe in motion, briefly aware of itself. An awareness, however, brief, however small, is the only thing in 250 million light years of gravitational pull that has ever stopped to wonder where it's going. So keep wondering. If you could somehow see the Great Attractor with the naked eye tonight, if the zone of avoidance simply didn't exist, and that enormous gravitational basin blazed across the southern sky, do you think knowing you were being pulled towards something that massive would change how you live your life? Or would you look up, feel the pull, and go back inside anyway? Tell me in the comments. I read every one, and I'll see you in the next one.